Hello everyone, welcome back to Introduction to Logic. Now we're going to spend some time talking about categorical syllogisms. A categorical syllogism is an argument that's been made out of categorical propositions. So let's jump right in. All right, so before you see a few different categorical syllogisms. These have already been placed in what is called standard form, which in classical logic, categorical logic, is very specific. In order to understand what standard form is, we first need to know the ingredients of a syllogism. Okay, so let's start by practicing labeling what form of proposition these are, right? So looking at number one, we have all humans are mortal as the first premise. We learned in the last lecture that if it has all or no, it has to be universal in quantity. The next thing we need to decide is if this is affirming something or denying something. And it seems pretty clear that it's an affirmative here, right? So we have a universal affirmative, which means that premise one, the proposition that's first here, is going to be an A proposition, okay? The second proposition is a tricky one. It's very unordinary. You're not going to see many like this in a common textbook or anything like this, but it says Socrates is a human. The thing that's tricky about it is that even though you know Socrates is one person, Socrates as a class makes things trickier. In effect, this is translated as another all claim. I'm saying all of the things that are Socrates, because there's just one, is a human, right? They are human. That's another A. It's universal once we understand that there's an implied all here, right? And finally, Socrates is a mortal. Again, it has this implied all, something that you won't encounter very frequently unless you are using a name as a class, okay? So once again, this is an A proposition. Okay, so just like individual propositions have subjects and predicates, so too do syllogisms have terms. The subject of your conclusion is going to be your minor term. So Socrates is the minor term. Socrates. The predicate of your conclusion is the major term. So the major term is mortal. Remember, the subject is always on the left, the predicate is always on the right. Now, that means there's one term left over, humans. Okay? Human, or what we call the middle term, is always going to appear in the premises, but never in the conclusion. So the middle term is that category that you do not find in the conclusion, right? Human. Okay, so why do we need to know this? We need to know how to find the minor, major, and middle term so that we can assess a syllogism's figure, okay? In order to assess the syllogism's figure. Now, before we get to that, back to standard form. Standard form always has the major premise first, and then the minor premise, followed by the conclusion. The major premise is the premise that contains the major term. So mortal is our major term, which means proposition one that has mortal in it has to be first, right? So this is already in standard form, which is good. You can't figure out an argument's figure until you have it in standard form. So the figure of a categorical syllogism is really just tracking the location of the middle term. There are 4 different possibilities, right? So there's possibility 1, 2, 3, and 4. Each one has conclusion. S is P. S is P. Okay. So for number 1, the middle term starts on the left, and then in the second premise is on the right. Okay. So it forms a slant like this. The middle term begins on the left, but it ends on the right. In the second figure, the middle term is all the way on the right, so P is M. Both times, S is M. So M represents your middle term. P represents the major, the major term. S is the minor term. Figure 3, M is P, and M is S. Once again, the middle term is connected, but this time it's on the left side. And then finally, we have P is M, and then M is S. Okay, so these are the 4 possibilities. Again, they're just tracking the position of the middle term. So since in number 1 here, and I already have the middle term highlighted for us, humans is forming a slant that's going kind of from the bottom up, right? It's leaning left, so to speak. We know that this has to be figure 1. Okay. Now that we have both of this list here and 1, we know exactly what this syllogism is. It's A1. I've given its mood, which is the list of its proposition types, and I've given its figure. Okay. Let's do the same for number 2. So for number 2, the first thing I want to do is find the middle term. Right? It looks like the middle term here is squares. Squares appears in both premises, but it does not appear in the conclusion. That's great. That means it's the middle term. Second thing I want to do is make sure that this argument is in standard form. If it's in standard form, I should have the premise that contains has 4 sides first. If it's not that way, I need to fix it. But it looks like that is true. Has 4 sides is the first premise. Great. So this is already in the standard form, which means I can go straight into labeling the kinds of propositions I have. Starting with first, all squares have 4 sides. Well, we already know that's going to be an A, right? We've got a lot of experience with those already. If it starts with all, it's going to be A. Okay? Some shapes are squares. So we know this is particular, but it's not denying anything. It's affirmative. An affirmative particular is an I. Okay? And then some shapes have 4 sides. It's doing the same kind of thing as our last proposition. So we have AII. Now, what's the figure? Well, let's refer back to our chart on the right here. You can also find this in the readings I've attached. It looks like we once again have this left-leaning figure, which is 1. So this would be AII 1. Okay, let's do number 3. All flying things have wings, no pigs can fly. Therefore, remember the tridot means therefore, no pigs have wings. Okay, so what is the middle term? It's going to be flying things, right? Can fly and flying things, we're going to say that's synonymous. Okay? Flying things and can fly. Let's now check to see if it's in standard form. Have wings should be in the first premise, and it is. Great. So it's already in standard form. We don't have to rearrange anything. All flying things have wings is going to be an A proposition. No pigs can fly is universal negative. Means it's going to be an E proposition. No pigs have wings again, that's E. Great. What's the figure? Well, once again, it's this left-leaning figure. So this is going to be AEE1. All right, last one. No iPhones are landlines. Some phones are iPhones. Therefore, some phones are not landlines. What's the middle term? It's going to be iPhones, right? So you can already tell our figure, once again, is going to be number 1, figure 1, right? But let's go through the process. No iPhones are landlines. We know that's E. Some phones are iPhones. That's I. Some phones are not landlines. This is our first O. So here, again, the figure is going to be 1. So E, I, O, 1. Okay, so that's all you need to know as far as determining what the mood and figure of a syllogism are, which are important steps. Why do we need to know the mood and figure of a syllogism? Well, technically speaking, there are only a certain number of kinds of syllogisms that are valid. And you could just memorize that list, right? For instance, all syllogisms that are of the form AAA1, those are all valid. That's what sometimes logicians call a syllogism in the form of Barbara, right? Barbara because it has the 3 A's in the name. They all have a name like that, right? So if you just memorized all of those things, once you determine the mood and figure of a syllogism, you could just say, oh, well, I know that's valid or that's invalid because it's of this form, right? There is another tool, however, that we can use to help us determine validity, and that's the Venn diagram, right? So let's do Venn diagrams now. This is what I'm going to be asking you to do in this class. So you start the Venn diagram the same way you did with propositions, but this time we need 3 circles because we have 3 terms. Once you have your 3 circles, you want to label them. You always have to label them, okay? So let's do first syllogism. Humans, mortal, and then Socrates. Now, it doesn't matter what order you label these circles in. I could have Socrates where mortal is, or I could have it where humans is. It doesn't really matter, just so long as you clearly label what circle designates what, okay? I recommend that you always start diagramming your universal premises first. Second rule, never diagram your conclusion. You're not diagramming the conclusion. You'll see why soon. So let's start with premise 1. All humans are mortal. I know because it's universal, I'm going to be shading. And specifically, I'm shading in order to rule out any human that is not a mortal. So all of this space here, where these humans are not mortals, I've got to get rid of this space, including where humans overlaps with Socrates. So long as it's not overlapping with mortal, I know nothing can be here. So I need to shade that space. Okay? Second proposition, Socrates is a human. If I'm going to do the same thing, but this time I'm blocking out all the space that is Socrates that isn't human. Okay? All the space that Socrates is not human. Again, shading means nothing can exist here. And that's it. You do not diagram the conclusion. So as far as the drawing is concerned, you're done at this point. The important task that's left is to evaluate your diagram for validity. So the way we do that is to see whether or not we have inadvertently diagrammed the conclusion. Socrates is a mortal. That would mean that there would be shading such that the only space Socrates can exist in intersects with mortal. And if you look at our diagram, that is true. The only space the Socrates circle has left now is in the mortal space. So I would say this is valid. That is a valid argument. Let's try again with number 2. First things first, you always give your 3 circles. Second thing, you label them. Squares, whoa. 4-sided, and shapes. Let's start with the first premise. All squares have 4 sides. It means I'm going to shade everything in the square circle that is not in the 4-sided circle. Okay? Just like this. Now, if you want to like fully darken in your circles, that's fine. It's just this program I'm using doesn't have a fill tool, so I'm not doing that. Second premise, some shapes are squares. I'm not going to be shading this time. I'm going to be putting an X down somewhere. Some shapes are squares. That means there's at least one shape. That means I need to put an X in the shape circle that is also in the square circle. And there's only one space for that. It's right here, right? This is the only space where squares and shapes overlap that we have not yet blocked out, okay? And that's it. You're done with the drawing. So now we check to see if we have inadvertently diagrammed our conclusion. Some shapes have 4 sides. In other words, is there an X where shapes and 4-sided things overlap? Yes, there is. So this is valid. Okay? It's another valid argument. Let's do number 3. Okay, label your circles. We have flying things. I'm just going to write flying here. We have wings. And we have pigs. Okay. I'm going to start with premise 1. All flying things have wings. So if it's a flying thing, it must also be in the wings circle. So I'm going to get rid of all of the space where that's not true. Okay. Premise 2. No pigs can fly. That means if there's any space where pigs and flying things overlap, I need to get rid of that space. So that's here. You can't be both a pig and a flying thing. Okay, and that's it for the drawing. The drawing is done. Now we check to see if we inadvertently diagrammed our conclusion. No pigs have wings. So there should be no space left unshaded where pigs and wings intersect. But it looks like we do have space where these two intersect that is not yet shaded. So I have not diagrammed my conclusion, which means I know this is invalid. Okay? It's pretty simple how this works. Once you understand how the shading works, determining the validity of a syllogism is pretty simple. Let's look at the last one. Okay, again, we're going to label them. iPhones, landlines, and phones. Okay, so I told you earlier that you should diagram your universal premise first if you have one. Right? There's a good reason for that. Let's say we didn't do that, right? And we diagrammed premise 2 first. Some phones are iPhones. Well, some phones are iPhones could go in many different places, right? It just needs to be some kind of area where phones and iPhones intersects. There's this area, right? And there's this area. Which one should it go into? Well, because we don't yet know, we actually have to put the X on the line. If it's not clear, like if there's a space where if there are multiple spaces where the X could go that you're trying to diagram, you have to put it on the line between those two spaces. Okay, so in this case, I would have to draw the line right there. It just means it's undetermined. It's undetermined where this X is supposed to go. Now let's diagram the first premise. No iPhones are landlines. That means any space where iPhones and landlines intersect, we've got to get rid of that space, which is all here. Now notice that that X I drew on the line earlier can't actually be on the line because I can no longer draw an X here. Nothing can exist in that space anymore. So the X is actually out here. That's why it's so important to diagram any universal premise you have first. So let's start from the beginning. No iPhones are landlines. So all of this space where iPhones and landlines connect has to be shaded. Nothing can exist here. Now, some phones are iPhones. That means there's at least one phone that is an iPhone. So I put an X here. That's the only space left for it to be. Okay? That's it for the drawing. So now we ask, well, is it the case that I've diagrammed some phones are not landlines accidentally? In order for that to be true, there would need to be an X in the phone circle that is not in the landline circle. And that's true. I have an X in the phone circle, and it's nowhere near the landline circle, right? So this would be valid. Okay, I'm going to do one more that should help you when it comes to understanding when to draw X's on lines. Okay, so let's say we have a syllogism that says something like, some pigs can fly, right? Some flying things have wings. Therefore, some winged things are pigs. Okay, a bit awkward, but it needed to be in order to make it in a standard form. Let's do our earlier classification of these syllogisms. First things first, let's determine what the middle term is. It seems to be flying things again, right? It's flying things. Okay. Notice this time that the middle term is not in figure 1, right? Instead, it is in figure 4, right? The middle term, when it forms an upward slant to the right, is actually figure 4. Now, we have an I proposition here, another I proposition here, and another I proposition here. So this is I, 4. So let's check it for validity. We are going to draw our circles. And then we're going to label them. Pigs. I'm just going to write flying. And winged. Okay. So, start by diagramming your universals. But we don't have any. Okay, so let's just jump straight to premise 1. Some pigs can fly. That means there needs to be an X in the pig circle that's also in the flying circle. But there are 2 places that could be. There's 2 places. That means we need to put the X on the line in between those 2 places. So the X goes here. Premise 2. Some flying things have wings. So there needs to be an X in the flying circle that's also in the wing circle. Now again, there's 2 spots that could be. So we have to put the X on the line between those 2 possibilities. Now we're done drawing, right? We need to check to see if we've accidentally, inadvertently, diagrammed our conclusion. Some winged things are pigs. That means there needs to be an X in the winged circle that's also in the pig circle. So it needs to either be here or it needs to be here. Okay? Do we have that? Well, there's nothing here, so that's not giving us anything. But notice that there's two x's on the line in this region that would make it valid. So is this argument valid? No, it isn't. Because these two x's are on the line, that means it could be in that space up above, or it could be in this other space, right? It could be, this x could be here, or it could be here, and we don't really know. We have no idea which space it's actually in. It's not in both. It's in one or the other, and we just don't know where. Okay? Which tells us that I cannot know with certainty that there is an x here. It might be that this one is actually here, and this one is actually here in the world. And in that case, wouldn't work, right? So this is going to be invalid. Okay? Going to be invalid. Remember, for an argument to be valid, the truth of the premises has to guarantee the truth of the conclusion. We're looking for deductive certainty here. Okay? So again, you put an x on the line when there are two regions it could go in. You don't know which one it's supposed to be in. You have to put it on the line in between those two regions. Okay, well, that's really it as far as our coverage of categorical logic. There are a few other things that you could learn, but for our purposes, that's enough to get going. Next time, we're going to start learning the basics of modern logic. So we're going to shift away from classes and categories and syllogisms in general, and we're going to shift towards modern logic. Okay? All right. Well, until then, stay healthy, stay safe.